Hello all, welcome to our channel Where to Know. So we'll continue working on the STM32 Nucleo Board. In this particular video, we will see what LED is connected on the Nucleo board in the schematic and to which pin it is connected. So we'll basically study the schematic and then we will use STM32 Cube IDE to program the STM32 board so that the LED Blinky code can be configured using the steps. And if any changes required in the code, we can do that, like adjusting the delay of the Blinky or whatever. And then we will see whether the Blinky code is working on the board or not. Few things, right? One, you get to know the schematic of the Nucleo and the connectivity of the LED. You get to know the STM32 Cube IDE, how to configure a pin, GPIO pin for toggling. And then you can also see whether in real board, whether it is reflecting or not. Let's start. So before getting to know where the LEDs are connected or whether there is a provision for LEDs on this particular board or not, we have to first get the schematic of the Nucleo 64 board. And the best place is to go to the website and get to the eval board page of this particular Nucleo board and see the required schematic. So now when you open, this is the page for the Nucleo 64 development board from ST, and if you see here, and in this you have to click on CAD resources. Okay, this is the computer aided design resources where you will have all the schematics, bombs, or any data related to the eval board, uh, data with respect to electrical, we mean. Okay, so now you can scroll down, you can see here there are project design files, manufacturing files, and then you also have schematic. Okay, in the schematic you can see here there is C03 as well as C04. MB1136 is internal naming to the ST micro, so that's how they name. MB might refer to motherboard, and C04 version or C03, which one you have to take depends on the board you have purchased. So on the board you will have numbering whether it is C03 or C04. We have C04, so we are clicking on C04, and this is the schematic. So here is the schematic, and then if you open, okay, the schematic contains power section. The schematic contains the Nucleo F411 STM32 controller section, which has LQFP64 part. This is the F411 part, and then if you go below, you have, and then we have STM32F103 CBT6. This is the ST-Link part of the STM32 Nucleo. So if you are new to the schematic, okay, you can actually understand the sections by seeing the title page here. You can see here, this is the top section and power, and for this you can see this is the MCU section. Okay, and this is for very pretty beginners, and you can see here title ST-Link. So if you don't understand the schematic and you are coming here for the first time, this is the way you have to at least first start and then go further depth into each and every section. So this is the ST-Link section. So what we want basically is where the LED is connected. Now we want LED to be connected to our main MCU, right? So here you don't see any LED in this page, okay? And then we don't, here you have some diodes and then some LEDs, but actually this is connected to the ST-Link. We don't want to control the LEDs that are connected to the ST-Link because this is the debugger section. We want the main controller pin. We want the controller to be connected to the LED. Okay, so now, and then we have the third section which basically is the extension connector. So we have talked in our introduction video, we have talked about the Arduino connector, we have talked about the Morpho connector. So this Arduino connector you see here, okay, and the Morpho connector are connected through some pins, and you see one LED here, LD2. Okay, so this is a green LED on the board with a series resistor of 510 ohms. Okay, if you are new to the schematic, you see some curves here. These are jumper shorting options. So that means if this particular connector, example sixth pin, has to be connected to PA5 pin, then this jumper has to be mounted. That means SB42 has to be mounted. And if this particular pin has to be connected to a LED on the board, SB21 has to be connected. Okay, ensure that SB21 and SB42 on your board are mounted so that PA5, if you actually search for PA5, okay, these are all searchable schematics. Okay, PA5, you see here, it's going to the bus PA15, and you can see here it is mentioning as PA5. Again, it is connected through the bus to the respective pin through the node name. Okay, so it says it goes to D13. Okay, so this is how you search the schematic. And this PA5 is not what we want. PA5, this is from STM32, the ST link. Okay, you can see here, it has come here and it's connecting to the Arduino connector and the LED. That means we want to control the PA5, toggle the PA5 such that this LED turns on and off. That is the intention. So in the board, let us see whether SB42, okay, and SB21 are connected or not. You see here, this is the Nucleo board, and as we mentioned previously, this is the C04. So you will also have similar naming on your board. Check that. And this is Rev C version of Nucleo. Okay, and as we go down here, these are all the jumper options. So I am not touching the board. EST is very important, so don't touch the board. And you can see here, I am going closer. This is the SB42, and you can see beside SB42 there is a 0 ohms that is mounted. That means the track is closed. That means there is a path. Okay, and then on the top here you can see 0 ohms beside SB21, which is mentioned as LD2-LED. So while designing, the users have given such a neat silk on the board so that people will understand, right? So SB21 is mounted, SB42 is mounted. That means the LED is connected to the respective GPIO. Now let us configure the STM32 Cube IDE to see how the configuration can be done and see whether LED glows or not. So in this video, we will see how to configure the STM32 Cube IDE to blink an LED. So once you open STM32 Cube IDE, you will see this window. Now go to File, New, STM32 project. That means we are creating STM32 project to blink an LED. Okay, so for now you can click yes. Yes, we need the files which are required. But what happens is, once you are trying to unzip, it might give an error. For now you can ignore this. In case if you are seeing such error, we will talk about that later, why you are getting that. Okay, and again, every step it tries to download the required files, but you get such error. And once it starts, you get a target selection window. Target selection window is something where you have to select your target. That means your target board. Right now we are having a board in hand, which is a Nucleo board. So click on the board selector, and again it tries to download the required files. Okay, for now you ignore this. Okay, and once the board selector tab opens up. Go to the commercial part number section, click on type Nucleo. Okay, once you type Nucleo, you see your board will get pointed here, like listed here, and you can click and it gets listed here. Click on this, click next. Okay, we want Blinky LED code, right? So let us uh, type that and then click finish. Don't make any other changes. So it is asking initialize all peripherals with the default mode. Yes, let us initialize the peripherals with their default mode. Okay, it takes a few seconds to open the .ioc file. This is the IO configuration file through which you can actually configure your pins on the microcontroller. See here, there are several pins which are highlighted in green, orange, and several colors. So these are the pins which are actually configured. Okay, now we want PA5. Okay, in this PA5 you can see PA5 is actually connected on the board to LED, to green LED. When you hover over this, you see the description. Okay, now this that means PA5 is already configured, but still if you haven't selected that initialize all peripherals, these wouldn't have configured. So in such case, you have to go to the system core, click on GPIO, and here you can see the pinout view. Okay, so the GPIO is selected, and you have the PA5, and PA5 has GPIO output level. That means the default state of this particular is selected as low. You can select as high as well. That means once the controller initialization, what is the state of that GPIO? Okay, and then the GPIO mode is set to output push pull. Yes. So if you drop down, you see here push pull and open drain. Like if you have interface like I2C, you will have a open drain interface. As you are configuring this particular pin for a toggling, you need output push pull, and you are not going to use any pull up and pull down, so you can keep it as is. Maximum output speed, for now we are not too much concentrated on getting accurate speed of the LED. We are just trying to make it high and low, and that means your entire configuration is ready. Right now close this. Okay, so here what happens is, that means you have the output that the .ioc file configured as per your requirement. Okay, so you have the ioc file, and then next steps will be to write your toggling code. Let us see how to understand these files and write the toggling code. Okay, so in this Blinky LED project that you have created, there is a folder called core. Okay, this core is the main folder where you will have the entire source and include files of the main project. And we know all the C functions start from main, so that means we have main.c in the source, and you can see the main.c is already having some code which is being generated by this .ioc configuration that we did. Okay, and this is the initialization clock in configuration, so you can actually get to know about them later. But what we did there, we did a GPIO initialization, which is PA5. Okay, so when we go here, we did you go to declaration, and here you can see the default state of LD2 pin written to reset, that means 0. Okay, and we also have the LD2 pin configured to push pull, no pull up or pull down, low frequency. So the entire configuration is very clear. Now we need to know how to toggle the pin, right? Now go back to the while one, and here to do that, first go to GPIO init and and you go to the GPIO write pin where the function is, and this is the GPIO dot C, which is the write, which is where the write function is defined. Below that, you will have something called the GPIO Hall GPIO toggle pin. So this is the function which actually toggles. So you can copy the function, okay, go to the while one, okay, and then you can actually define the function, okay, and we want the PA5, right? That means the port will be port A, which will be defined by GPIO A, and the pin is GPIO underscore pin underscore 5. You might ask how we know this. Okay, so for this you double click and right click and go to open declaration. Okay, you can see here the GPIO-A is a macro that is defined in the header file of this microcontroller, and then GPIO pin 5, if you go, this is defined in the GPIO.h. So that means the PA5 pin is configured here, and there is a inbuilt function in the HAL which is HAL underscore delay. Let us try to use that, and let us make HL delay whatever the value we put here, this will create that much milliseconds of delay. That means we are actually creating 200 milliseconds of delay. So here we are actually first toggling and then waiting for delay, again toggling. So that means we actually, if you go to the function of this particular one, you can see here it's just trying to negate every time that particular pin. So that means first it will be high, wait for the delay, again the toggle pin function comes up, again it toggles to high, again delay low. So that means the sequence continues. So once this is done, try to use this hammer symbol to build the project. Okay, so once you click on build, see, you see build finished, 0 errors warnings. That means you are ready to go. And if you want to run this, okay, click on this particular run symbol. Okay, so what you can do is it is saying unable to launch. Okay, what is happening is, that means the particular launch related functionality is not enabled. So let us just try to get that done, and for that go to the run window. Okay, and what you do is run as STM32 Cortex M C++ application. Okay, that means there is a application perspective that is created, and you can see here it starts running. Okay, now you can see on the LED, okay, the LED on the board which gets blinked. Okay, if you want, now as the perspective is set, now it runs automatically without any issues from the next time. Okay, so download verified successfully, shutting down and exit. Okay, so the LED is blinking at our required frequency. Now if you want, you can actually change this to whatever frequency you want, and you can just try to run. Once you run it, it builds, and it downloads the code. Can see it detects, it downloads the code, and the LED blink happens as per our requirement, which is around 10 seconds, right? 10,000 milliseconds is 10 seconds. Okay, so you can, if you have a board, you can see that the LED blink happens on the board. So we have the Blinky LED code which is working, and we have the entire from starting from the scratch till the whole code we have run through. You can build on top of this, configure your pins for various functions. In the next videos, we will talk about various other functionalities. Thank you.